To delve into the creation of the universe, we must start approximately 13.8 billion years ago, with an event so monumental that it set the stage for everything we know today. This event is known as the Big Bang, but what exactly was the Big Bang? Imagine the universe as a tiny, infinitely dense point, smaller than a subatomic particle. This point, known as a singularity, contained all the energy and matter that would eventually become everything we see around us. This singularity was not in a purely existing space, but rather contained space itself. The Big Bang marked the beginning of both time and space. In the very first moments after the Big Bang, the universe was incredibly hot and dense. It rapidly began to expand and cool. As it did, the fundamental forces of nature, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force began to differentiate from a unified force. Within just a few seconds, the universe cooled enough for protons and neutrons to form from the quark gluon plasma. These protons and neutrons then combined to create the first atomic nuclei in a process called nucleosynthesis. As the universe continued to expand and cool, these nuclei captured electrons to form the first atoms. Hydrogen and helium were the primary products of this process, and these simple atoms began to clump together under the influence of gravity. Over millions of years, these clumps of gas formed the first stars and galaxies in a period known as the cosmic dark ages, where the universe was filled with dense clouds of hydrogen and helium and no visible light. The formation of the first stars, known as population 3 stars, was a significant milestone. These massive stars were born from the primordial gas and burned brightly for only a few million years before exploding as supernovae. These explosions dispersed heavy elements such as carbon, oxygen, and iron into the surrounding space. These elements were crucial for the formation of subsequent generations of stars and planets. As galaxies began to form, they gathered vast numbers of stars, gas, and dust into large clusters. Our galaxy, the Milky Way, began to take shape about 13 billion years ago. The formation of the Milky Way was a gradual process involving the merging of smaller proto-galaxies and the accumulation of gas and stars. Around 4.6 billion years ago, in one of the spiral arms of the Milky Way, a cloud of gas and dust began to collapse under its own gravity. This process led to the formation of our Sun, a Middle Ages star that would become the center of our solar system. As the Sun formed, the remaining gas and dust in the surrounding protoplanetary disk began to coalesce into planets, moons, asteroids, and the early Earth, like the other rocky planets, was a hostile environment with intense volcanic activity and frequent collisions with other celestial bodies. It took millions of years for the surface to cool enough for liquid water to form, creating oceans. This was a critical moment in Earth's history, as it set the stage for the emergence of life. Life on Earth began approximately 3.5 billion years ago with simple single-celled organisms. These early life forms were microscopic and lived in the oceans. Over time, these organisms evolved, leading to the development of more complex forms of life, including plants and animals. This process of evolution, driven by natural selection and genetic variation, eventually gave rise to the diverse biosphere we have today. The evolution of life on Earth was accompanied by dramatic changes in the planet's atmosphere and climate. For instance, the Great Oxygenation Event, which occurred around 2.4 billion years ago, was marked by a significant increase in atmospheric oxygen produced by photosynthetic organisms. This event allowed for the development of aerobic life forms that rely on oxygen to survive. As life evolved and diversified, the complexity of ecosystems increased, from the first simple microbes to the rise of complex plants and animals, and eventually to humans. The story of life on Earth is one of adaptation and survival. Humans, with their advanced cognitive abilities and complex societies, have developed a profound understanding of their place in the cosmos. Today, our understanding of the universe continues to evolve. Observations from powerful telescopes, such as the Hubble Space Telescope and the James Webb Space Telescope, have provided us with stunning images of distant galaxies, nebulae, and other cosmic phenomena. We have discovered exoplanets orbiting distant stars, and have even detected gravitation waves ripples in spacetime caused by some of the most energetic events in the universe. The universe is still expanding, and scientists are studying its rate of expansion to understand its ultimate fate. The study of dark matter and dark energy, mysterious components that make up most of the universe's mass and energy, continues to challenge our understanding of fundamental physics. The story of the universe's creation is a grand tale of transformation and growth, from the singularity of the Big Bang to the vast, complex cosmos we observe today. Each new discovery brings us closer to understanding the fundamental nature of the universe and our place within it. The quest for knowledge about the universe is a journey without end, driven by curiosity and the desire to uncover the mysteries of existence.